Though the details differ somewhat, all garbage collectors work by splitting the heap into different generations. These are called old generation and the young generation. And then these generations are further divided into different spaces. So, generational collection is a broad topic, and that we will discuss in the next part. Let's first explore the different categories of garbage collectors that JVM offers. So, there are five types of garbage collectors that are available by the JVM: the serial collector, parallel collector, concurrent collector, although it has been deprecated as of JDK 9, the G1 collector, and the Z collector. Let's explore one by one. The first we have the serial garbage collector. It is used for single CPU machines. The serial collector uses a single thread to perform all garbage collection work, which makes it relatively efficient because there is no communication overhead between the threads. It is best suited to single processor machines because it can't take advantage of multiprocessor hardware, although it can be sometimes useful on multiprocessors for application with small data sets, let's say for up to 100 MBs. But that's a very rare scenario. Serial collector is selected by default on certain hardware and operating system configuration or can be explicitly enabled with the option Java-access plus use serial GC-Z name of the application .java. That's the command line option to enable the serial garbage collector. This is the simplest GC implementation. It is basically works with a single thread. That's why it is simplest. And this GC implementation, because of its nature of working with a single thread, freezes all the application threads when it runs. So therefore, it's not a good idea to use it in a multi-threaded application, like in a server environment. Next, we have the parallel garbage collector or the throughput collector as we call it. It is a generational collector similar to the serial collector, but the primary difference between the serial collector and the parallel collector is that the parallel collector has multiple threads that are used to speed up the garbage collection. The parallel collector is intended for applications with medium size to large size data sets that run on multiprocessor or multi-threaded hardware. To enable this, we can use the command -access plus use parallel GC. It is the default GC of the JVM as well. If we use this GC, we can specify maximum garbage collection threads and pause time, throughput, and footprint, etc. The number of garbage collector threads can be controlled by the command line option -access parallel GC threads, and then we can specify the number of threads. The maximum pause time goal can be specified with the command line option -access max GC pause millisecond, that means, and then we can specify the time gap in millisecond that you want to have between the two garbage collection phases. Now let's talk about the next garbage collector, which is the concurrent garbage collector or the CMS as we call it, concurrent mark sweep implementation. It uses multiple garbage collector threads for garbage collection. It is designed for applications that prefer shortest garbage collection pauses and can afford to share processor resources with the garbage collector while the application is running. To put in simple words, applications using this type of GC respond slower on average but don't stop responding to perform garbage collection. The command line to enable this particular GC is -access plus use pair new GC and then -jar and name of the application. As of Java 9, the CMS garbage collector has been deprecated. So if you will use it, the processor will show you a warning. Then we have the G1 collector as well. And according to the official docs of the Oracle, the concurrent mark sweep CMS collector, and the garbage first G1 collector are the two mostly concurrent collectors. Now, what is mostly concurrent collector mean? They perform some expensive work concurrently to the application, but mostly, not all the time. The G1 collector or the garbage first collector is for multi-processor machines with a large amount of memory. It meets garbage collection pause time goals with high probability while achieving high throughput. G1 is selected by default on certain hardware, and where it is not, we can enable it by using the -access use G1 GC command. Now you must be wondering, why is it called the garbage first? It is called garbage first because of its approach to garbage collection. After the mark phase is complete, G1 knows which regions are mostly empty, and it collects in these areas first, which yields a significant amount of free space. So that's why its approach is garbage first. Next, we have the Z garbage collector or the Z garbage collector, as you can call it. It is a scalable, low latency garbage collector. JetGC performs all expensive work concurrently with stopping the execution of application threads. It is intended for application which requires low latency, less than 10 millisecond pauses, or use a very large heap size, let's say in multi terabytes. We can enable it by using the access -access plus use JetGC option from the command line. JetGC garbage collector debuted in Java 11 as an experimental feature for the Linux, and then JDK 14 introduced it under the Windows and Mac OS. JetGC has obtained the production status from Java 15 onwards. So now it is available to use, and it is a very useful garbage collector for the large applications with larger heap sizes. And there's a lot more to discuss about the G1 and the JetGC. We'll try to cover that in the next part.